Questions 21 through 25 on the 2003 Grade 7 Gauss Math Contest. In a large hospital with several operating rooms, 10 people are waiting for a 45-minute operation. The first operation starts at 8 a.m., the second at 8:15 a.m., and each of the other operations starts at 15-minute intervals thereafter. When does the last operation end? So you have 10 people, correct? And they are all waiting for some operation. So 8, 9, 10. And each of them is starting at intervals of 15 minutes. So the first one is 8 a.m., like that. And then 8:15, and so on. So I'll write those in. So that is basically the schedule for when each of these operations begins. Now they're asking, when does the last operation end? So the 10th patient starts at 10:15, and since each operation is 45 minutes long, his or her operation will end 45 minutes later, which is 11 a.m. So therefore, number 21, the answer is D. Luke has played 20 games and has a 95% winning percentage. Without losing any more games, how many more games in a row must he win to reach exactly 96% winning percentage? So currently he has a 95% winning percentage for the 20 games that he played. So 95% times 20 is 19. So he's won 19 games so far. Now we want him to win more games, that X representing the number of games that we want him to win, so that his average becomes 96%. Now to figure out an average, we have to divide by the total. So the total is going to be 20, which is what we started with, plus an additional X. So that's the equation. So now let's cross multiply 19 plus X, and then 20 plus X times this 0.96. like that. So you have 19.2 plus 0.96x is 19 plus x. And then x minus 0.96 is 0.04. 19.2 minus 19 is 0.2. And then therefore x is 0.2 divided by 0.04, and x is 5. So he's got to win 5 more games, and let's verify this. If he does, he initially won 19, right? So if he wins 5 more games, he's going to have won 24 games. And if he plays 5 more games, then the total number of games is 25. And this is indeed 0.96, or 96%. So 22, the answer is D. A different letter is painted on each face of a cube. This cube is shown below in 3 different positions. What letter belongs on the shaded face of the cube in the following diagram? So this is one of those visualization questions, trial and error, that kind of thing. So here we go. All right. So the first cube, what I'm going to do is I'm going to draw it out as if it was kind of unfolded. You know what I mean? But keep in mind, look at the letters. They're kind of twisted and turned, and they've done that for a reason. That's going to help you, in fact. So when you flip these, open them up, ensure that you draw those letters in the same way, because that is very important. So the first one, I kind of just opened it up. The second one, the same kind of thing. And ensure that you don't change the orientation of the letters. So if that's X, that's F, and A is on its side like that. Okay? And the third one, let's see what we got. Oh boy. We got A on its side, and then we've got E looks kind of like this on its bottom, I guess, and then X is right here. Okay? And then the one that they want us to figure out is A, F, and some letter. So we got F here, A is upside down, and then this is the shaded region. Okay? So here we go, trial and error. Now, all cubes, if you were to unfold them, they kind of look like this. You got two flaps on either side. So what I'm going to do is just see what I can get. If I don't get it correct, I'll try another way. No problem, right? That's what trial and error is all about. So the first thing is, since our shaded region involves F and A, I'm going to start with the one that has F and A in it, right? Why not? So I'll put the F here, and then I'll put, well, what do I do now, right? I mean, it doesn't look like this. This doesn't look like I can match it in there. So what we can do, since it's a bit confusing, we can go back to this guy and make it look a little bit better, or a little bit in line with what we want to do. So I'll do that in the following way. So I've got to make it look like this, where F is here, using this guy. And I can most certainly do that. I'll just put the X over here. And that means the A is over here. Okay? Entirely, I haven't changed anything. I'm just different orientation. So that means the X goes there and the A goes here. Okay? So far, no problems. And then now let's look at this one. The shaded region is after the F. So that means this is the shaded region. Correct? Now we've got to figure out what goes in here, what goes in here, and what goes in here. Okay, let's look at these guys here. This one here, E, V, and T, the three completely separate letters, so that doesn't help us at all. Now this one is what we already filled in. We just had to rearrange the orientation. So that leaves us with this guy, A, E, and X. Well, when I look at this, it doesn't really look like that, right? Because in this one, A and X are bordering each other right here. And this one here, A and X are not bordering each other. So, no problem. That's what trial and error is all about. We have to approach it in a different way. And we will. No problem. So here we go. Let's start all over. So now, I'm going to, of course, concentrate on this guy right here, because that has the A and the F that is similar to the region that is shaded. So I will put it in a slightly different way. I'll put the A here, I'll put the X beside it, and I'll put the F down here. Okay? So basically what I did is I looked at this and I flipped it. So since F was on the top here, I put F on the bottom here. All right? Because I have to do it differently than here, otherwise I'll end up getting the same result. And now therefore, this now becomes the shaded region, if you look at this right here. All right, now let's proceed. I've got to find this one, and I've got to find this one, and then finally the shaded region. Okay, so again, let's go to this one, E, V, and T. Well, that's not similar in any way to what we have here in the orange diagram, so that's not going to help us. But how about this one here? A, E, and X. Okay, that is similar because there's an E there. So without changing the orientation, I've got to put in the E right there. Okay, so we are making progress. Now I've only got two letters left. Right there. And what are those two letters, by the way? What were all of our letters? We had A, E, F, X, a T, and a V. I guess this is an alphabetical order. No, it's not. It doesn't matter. So I've used up an A, E, F, and X. So I've got T and V as my possible choices. So where does the T go? Where does the V go? That's the final challenge, I guess. And that is a bit challenging, but I want you now to concentrate on, obviously, this diagram. That's going to tell you where the T goes and where the E goes. Look at the orientation of E. So the fact that they have all these letters in a certain orientation is the key to this question. A lot of people miss that. They think, well, who cares? I'll just draw my V like this. It's going to be the same thing. No, it's not going to be the same thing. Same thing how if you drew the A like this, it would not be the same thing. So since the E is like that, you might have to turn this page upside down. The T and the V are in specific conditions, specific positions, I should say. So the T looks like it will be like this, right there. Okay, if you look at this cube and turn it upside down, you might have to turn the page upside down. You'll be able to see that that is the only way this is going to work. And therefore, the only other space that's left has to be the final letter, which is V. So there you go. A lot of bit of trial and error here, visualization, but I think with a little bit of practice, you'll be able to get this. So 23, the answer is E. In the pattern of numbers shown, every row begins with 1 and ends with a 2. Each of the numbers not on the end of a row is the sum of the two numbers located immediately above and to the right, and immediately above and to the left. For example, in the fourth row, the 9 is the sum of the 4 and the 5 in the third row. If this pattern continues, the sum of all the numbers in the 13th row is. Well, I don't think you will have to write out all 13 rows because that would take a lot of time, and as you know, on math contests you have a limited amount of time. So let's just do the first, few rows. And the first few rows actually they've already done for you. 1, 3, 2, like that. Now, before I create any more, let's just understand what it is that they are telling us. How did they actually get these numbers? Well, they explain it to you that the first number is always a 1 in any row. The last number is always a 2. Now the middle numbers, how do you get those? Well, you look at the two numbers above it. Immediately above and to the left, immediately above and to the right, and you add them. So in this case, 4 and 1, 4 plus 1 is 5. That's how you get the 5. And very similarly, 9, you look at the numbers immediately above, to the right and to the left. 4 and 5, 4 plus 5 is 9. And obviously for 7, same thing. You look at the two numbers above and to the right and to the left, 5 and 2. 5 plus 2 is 7. So that's how they get those numbers. So using those rules, you can easily figure out these rows. So I'll just put it in. I'm sure you can do it. I don't need to explain every single number. So this is going to be in rows. So I'll write the rows behind here. Go 1, row 1, row 2, row 3, row 4. And I'll just write, I think 3 more rows should be sufficient to explain the pattern, because there's obviously going to be a pattern. And the pattern is the sum. So in this row, the sum is 1 plus 2, which is 3. In this row, the sum is 1 plus 3 plus 2, which is 6. In this row, 1 plus 4 plus 5 plus 2, which is 12. And in this row, the sum is 24. You perhaps already see a pattern. But just in case you don't, I'll just keep going here. So I've got 1, 6, 14, 16, 9, and 2. Sum of these numbers is 48. On 6th row, 1, 7, 20, 30, 25, 11, and 2. The sum of this row, the numbers, 96. One more row, because I think by now you figured this out. 1, 8, 27, 50, 55, 36, 13, and 2. The sum of the numbers in this row are 192. Well, you know by now that this sum has a pattern. The sum doubles every row. Correct? So there you go. So without having to write out all the numbers, we can figure out the 13th row. So this is 8, 9, 10, 11, 12, 13. The sum we can figure out. So the sum of the 8th row, we continue here, will be double 192, which is 384. The sum of the 9th row will be double that, which is 768. 10th row will be 1, 5, 3, 6. 11th row will be 3072. 12th row will be 6144. And finally, the 13th row will be 12,288. That will be the sum of all the numbers in the 13th row. And I think that's what they're asking. Yeah, sum of all the numbers in the 13th row. So 12288. So 24 is D. The digits 1, 2, 3, 4, and 5 are placed in one of the boxes so that the resulting product is correct. If each of the 6 digits is used exactly once, the digit represented by the question mark is. So again, this is another trial and error question. Is there a systematic way in terms of like a mathematical formula, And perhaps, but the truth is that describing it in that way is actually more confusing than trial and error, and more time, not just confusing, but more time consuming. Confusing and time consuming. So I'm just going to show you trial and error. And I really believe that this is the best way to do it on a math contest. So what I'm going to do is I'm only going to concentrate on the top 2 numbers. Okay? And very quickly you can make a list of the top 2 numbers. 1, 2, 1, 3, 1, 4, 1, 5, like this. You understand? 1, 6, like that. And very quickly I can do that for all of these, so I'll just write it all out. So these are the possible numbers that could be up here, a 2-digit number. And now, of course, we're multiplying by a 3rd digit. So we'll just trial and error this. All right. So here we go. Now, if that question mark, I'll put it up here. Let's say it's a 1. We'll start with 1. Then that means that we can't use any of these guys, right? Because we can only use each digit once. So we also can't use anything that has a 1. So all this is out. All right? So we can only use the remaining 2-digit numbers. But if you do multiply 1 by any of those, it's the exact same thing. You don't get a 3-digit number. So in a very quick way, 1 is not possible as the question mark digit. So that's great. We can now move on to 2. So let's say the question mark digit is 2. Well, then we have to eliminate these guys because you can't use them because they have 2's in them, and each digit can only be used once. And similarly, I've got to take out any number that has a 2 in it, so all these guys. All right, these guys are all gone. Now we proceed with what's left. 2 times any of these have to give a 3-digit number, and that's not going to be possible for a lot of these. The only time you'll get a 3-digit number, I think, is when you get up to 51. Yeah, because 2 times 46 is 92, right? So let's see. 2 times 51 is 102. 2 times 53 is 106. 108. 112. 122. 126. 128. And 130. So very quickly we did that. Now the criteria is that the 3-digit number has to contain the other 3 digits that we had not used yet. And 0 is not one of the digits at all. So that's no good, that's no good, that's no good, and that's no good. And no digit can be used more than once. So that's no good, that's no good. All right, let's see this guy here, 126. How did we get 126? It was 2 times 63, correct? And that is 126. No good because the 2 is being used more than once. And then 128 is obviously no good because there's an 8 in there. So 2 cannot be the question mark. All right, so you see how the trial and error. So let's hope that the next one we can get it, which would be a 3 as the question mark. So here we go. Let's try 3. If 3 is indeed the question mark digit, we have to eliminate these guys because they have 3's in them. And we also have to eliminate anything that has a 3. So these are gone and these are gone. All right, let's go. Let's go ahead with this. Similarly, if you multiply 3 by any of these 2-digit numbers, it must produce a 3-digit number because that's the criteria. And I think that only happens when you get over to this side here, 41, because 26 times 3 is 78, right? All right, so 41 times 3 is 123. I'll just do these here. 42 times 3, 126. 135. 1. So there you go. I multiplied them all by 3 to see what we can get. All right, so 41 times 3, this guy right here, times 3, is 123. Is that good? Well, no, because we've already used 1 and 3, and that product has a 1 and 3. Because remember, all these digits can only be used once. So, no good. 126, same thing. There's a 2 there. That's not going to be good. 135, no, because it's got a 3 in it. 138, well, it has an 8, and 8 is not even part of our criteria or selection. How about 153? Well, no, because there's 2 5s. How about 156? Again, 2 5s. How about 162? Well, let's see. We have 54 as our 2-digit number. Our question mark is 3. And then that gives 162. I believe we have it. Each of these digits is only being placed once. 1, 2, 3, 4, 5, 6. There you go. We got it. And therefore, the question mark digit is 3. So as you can see, without too much pain, we got this answer correct with trial and error. So number 25, answer is B, which is 3.